Here we go. Yikes.
You're watching PTZOptics Live, a 1080p broadcast available exclusively on YouTube Live every Friday, streaming at 11 a.m. Pacific, 2 p.m. Eastern. Broadcast quality made affordable. Thank you for tuning in.
Hello, everybody. Welcome to PTZOptics Live. We've been having a heck of a time getting this stream going, but I think it's good. Thank you for being here, Andrew, and sticking with us here.
It's my pleasure. It's way more fun this way.
So we're going to jump right into the interview here. I'm going to assume that our viewers out there watching this live or on demand knows a little bit about NDI. So we're going to there'll be a little bit more technical, I think. So let's just go ahead and start off with NDI 3.0. Can you tell us get us up to speed? Because I think a lot of us know what NDI is, but 3.0 I think is a new kind of thing that we'd like to hear more about.
Okay, so NDI 3.0, we've actually introduced probably some of the biggest steps yet in NDI. Now, probably the number one, at least at a marketing level, is going to be that we support multicast on NDI now, which means that if you want, you could be producing a 4K stream on NDI, and you could distribute it to your whole company with 100 viewers at once, 200 viewers at once. You'd get basically perfect quality video, incredibly low latency, to unlimited number of viewers. Now, I should caution that multicast in the real world takes some actual setup. Our experience has been that when we first switched this on, we managed to bring our whole network down, and our IT guys came, hunting me down to ask me what on earth we were doing. And it turns out you have to configure your routers properly for multicast. But once you do it, it works awesome. And so you can obviously, this means that any NDI sender can send to an unlimited number of people. Now, we've not just done that. We've improved the way metadata works. We've improved the way timing works. We've added much better NDI tools. And of course, we've introduced NDI-HX, which in many ways is the holy grail, because since NDI has come out, since everybody's accepted that the world has been moving to IP, there's been no really practical way to actually get real world cameras that exist today actually working with IP. So everybody kind of thinks, well, it's going to come, and every trade show they come and say, okay, is there a camera yet? Is there a camera yet? And so we came up with this concept of NDI-HX, which was to make it so that it is easy to integrate devices into NDI. And so that's obviously a very big thing, and we've worked, ourselves and with you, PTZOptics, to help start bringing real world devices into NDI. And if anything, that's the biggest thing, because to me, when we came out with NDI 1.0, well, that was 3 years ago, we all knew where the industry was going. And I think that there was this huge buzz around NDI. NDI, it got integrated very quickly, far quicker than I ever expected, into hundreds of applications. And yet it did all this stuff, and there was like all this energy on this side, and then you have kind of cameras where everybody knows that they do IP, they are all digital these days, and yet the two worlds never came together. And it was always going to be the magic of when those two worlds came together that really jump-started the IP revolution. And so that is, what NDI-HX is meant to do, which is kind of a bridge between real-world devices and NDI. And so, those are some of the big things in NDI. We've kind of gone one step further, and we've standardized the way PTZ control works. That means that, if you think about how PTZ has traditionally worked, you've had a camera, then you've connected that to your computer somehow, probably HDMI or SDI. You've then needed to work out separately how to get tally back to it. You've had to work out separately how to bring the audio, probably via analog. Maybe it was on the SDI embedded. Then you're going to work out, okay, it's running Visco, or it's running the Panasonic protocol, or what the IP address is. And so you put all of this stuff together, and it's incredibly complicated. And so we've actually built into NDI this concept where you connect your application to the camera, and now every part of how they talk works, so that the PTZ control just works. You don't need to configure that separately. It doesn't matter what the camera's protocol is. We'll work, with them as long as they support HX. And so we've really solved a huge part of getting, of setting these things up and making them truly plug and play. So that's been the goal. I'm sure there's going to be some things we're going to learn as we put this out in the real world, but that's been our goal.
Well, I think NDI-HX is what we've all kind of been waiting for, because we've had these cameras and it's been difficult to integrate NDI in, and we couldn't really have a ship date. And now, so can you explain to me, what did NDI-HX do for those of us out there? Like, is it different from true NDI, or is there like a sacrifice that's being made? I know that what I'm seeing is great quality, but I'm assuming that maybe more compression. Like, I just don't know too much about it, but the quality looks great and the latency is really, really low. So what kind of magic are you working here to make this all happen?
Well, so NDI-HX, the basic, so NDI-HX, what we've done is we've said, you know, we a big part of this is we've said we're going to work with specific, you know, with some small number of important vendors, of which PTZOptics are one, to collaborate on starting to get devices to market. So at this point, every device, in order to get to low latency, high quality, automatically discovered, full PTZ control, all of those pieces, you know, our goal is, how can we make NDI work with a camera that exists today? And so we're working with as many companies as we can, and focusing with the, you know, the really important ones first, to collaborate on getting those two pieces working together. And so, yes, I mean, it requires us to sit and tweak. And I know that, you know, like with yourselves, we've had changes made to the firmware so that it can all work. We've come back to you and said, okay, how on earth there's this problem? How on earth do we get this to work? And by working together, we've actually managed to take, you know, really I often use this term in engineering at NewTek, which is Mars rover engineering. And what I say is that, you know, NASA sends this rover to Mars, and they sent it off 5 years ago, and somehow they have to make it do things that they had never considered that it would do. And that's what we're trying to solve here by working closely with partners like yourselves, where we're sitting down, we're getting together, and we started talking to you about this well over a year ago, about how we can take what's in your hardware today, how we can customize it to solve some of the things that makes it not work with NDI, and then we can put all of this together and manage to make it work with NDI. So that's a very complicated, maybe technical, you know, decision. But, you know, to answer, or the technical discussion, to answer your question, yes, it uses different compression. But we have worked around, so you know, with your cameras have H.264 encoders, but we're running high bit rate H.264. We're not running, you know, low bit rate streaming H.264. So this means that we can work with encoders that exist today, for instance. And it is customized so that, you know, that there are firmware changes that you've made that allow us to it's not just a regular stream. We're doing some clever things on top of that to manage to get to very low latency, to get to very high quality, and to make it actually integrate and work well with the, you know, there's a lot of pieces to putting this together reliably.
And we have a question about bandwidth, which I'll ask you when we get to that. But one of the things that I think a lot of people are excited about, and I put on the agenda, is wireless NDI. How have you made that possible? And you, even in the pre-show, we were talking about multicast-enabled Wi-Fi routers. So we can actually take our, traditionally, what I always thought of as NDI was local area network, hardwired, 100 megabits, but now it sounds like we can do this over Wi-Fi, so it's kind of a big change for, is this an NDI 3.0 thing that's kind of new?
Yes, and half. I mean, we made first little baby steps that direction in NDI 2.0, and if you go and look back at the press release, for instance, we had talked a lot about mobile, and a big part of this is this realization that much as I think a lot of us come from the desktop world, and in the broadcast industry, we're tending to talk about, you know, what we've been used to for 20 years, that the world at large is moving towards wireless, and is moving towards mobile devices, and is moving towards, you know, low power portable devices. And, you know, we started well over a year ago working on making NDI so that it can integrate into that world. And obviously, so you can use our iPhone application today, and it works okay. I mean, it worked as well as we could make it a year and a half ago. With everything we've done with NDI-HX, which allows us to use basically encoders built into hardware devices that are low power, we can do an awful lot better than that. And then when you're talking about things like our Spark, Connect Spark product, where we really have customized the firmware on that device completely. I mean, it is not the traditional way you would typically do these things. We've got right the way up to doing full multicast, full multicast NDI over wireless, which means that even on a wireless network, you could have really as many devices connected and listening as you want. And even though we are running what is probably considered relatively high bandwidth here, because we can do this multicast, obviously you can still send to a huge number of people at once, and it doesn't matter if you have video monitors on different computers, you're bringing it into vMix like you are somewhere else. It all works, and it looks great, of course.
Well, that's incredible, and I think there were a lot of questions that guys were like, you have to ask. One of the things Gary Batan said, you got to ask him. He thinks that you guys should probably certify Wi-Fi routers, because people are going to want to put these, Connect Sparks everywhere, and they might not have a multicast-enabled Wi-Fi router, or they might not have a Wi-Fi router that can handle all the bandwidth. So that was one of the suggestions our engineers said is Ruckus Wireless is a very high-quality wireless router company that is kind of built for video. Would that be? Do you have any suggestions there?
Well, so first of all, I want to throw a term out there, since a lot of people are starting to think about this. The number one thing that you need to make multicast work on any network is you must enable something called IGMP spoofing, IGMP snooping on the router. Without that, multicast just flat out does not work. And if you put a high bandwidth like full NDI onto that network, it'll probably cause all manner of grief, because basically a lot of routers treat multicast traffic like it's broadcast traffic. So the very first version we got NDI full NDI running with multicast, we switched it on, and suddenly our whole network came down because we have over 200 computers, and we were sending, it was 4K, so we were sending 200 megabits a plus to 200 computers at once. And needless to say, quickly the IT guy came running over, and so we had to go back and work out how to get our network fully configured for multicast. But in regards to wireless routers and certifying routers, generally our goal with NDI is for it to work in the real world. And I kind of feel like it's a failure on our behalf if we don't work on every common device and there's not some way to make it work. So if there's not some way to make it work, we would probably consider it a bug, and we would try to do something about it on our end. I feel like we have somewhat lost the philosophy of NDI when we're needing to certify routers. Our goal is to make IP video accessible to people. So I mean that's our philosophy, and honestly, if somebody called us up and said this router just will not work, as long as the router wasn't busted and everything had been done on the settings that could, we would devote serious time to trying to make it work. And maybe at some point we would give up, but our philosophy is we're going to try to make it work, because the IP revolution is about enabling everybody to use IP. Now, after all that said, obviously some routers are going to do better than others, and I would strongly recommend that people do pay attention to this. And so, really the right answer is always going to be get people to use the best equipment you possibly can. But at the same time, us on our end, we need to do everything we can to make sure that all equipment works. And so if you combine those two things, hopefully everybody gets a good experience.
Well, that is really good to hear. I know that there's huge differences in gigabit switches. You can buy one from Cisco and you can buy one from China, and they're quite different. But let's go to our next question about bandwidth. You mentioned a 4K stream, at 200 megabits. Word through what I've heard through the grapevine is that NDI-HX testing has been really, really low latency. 30 to 50 megabits per second, 30 to 50 milliseconds of latency, which is extremely low. But what I've heard is about 10 megabits per second of bandwidth. Would you say that's correct, or are you saying that maybe it's the same as a normal NDI stream, or where does NDI-HX fall in terms of bandwidth?
Okay, so NDI-HX, I mean, the HX, it stands for high efficiency. Don't ask me how E became X, but it sounds cooler to say HX. But it stands for NDI high efficiency, and so it does run low bandwidth. It runs in the range of 10 megabits. But as I've said, what we've done is we're working specifically with the important vendors like yourselves to start with, and we, most importantly, because we're at this point we're still customizing HX to work really well with every device that we support. And so I don't want to promise that the bandwidth is always going to be exactly the same, because we want to make sure that the video quality looks great. but it is in the ballpark. What we have typically found is that about 10 megabits and maybe slightly above is the point at which it looks as good as, I mean, it's imperceivable, and even in just terrible footage, that is the point that we get to. And I should say, you can't directly compare this maybe with, say, streaming at 10 megabits, because we're doing things that aren't the same as streaming. There are things that we can take advantage of that others couldn't. So, for instance, and I'm really getting into the details here, we can run with incredibly long group of pictures. So we don't need iframes. We know when we're connecting and not connecting, and so we get control over how the stream is being produced that wouldn't normally be the case. And so we can do some things to get much better bandwidth than one might possibly normally imagine. Hopefully, no, it works really well.
And the latency is really, I feel like seems to be like the huge hurdle that you've overcome, and that's the biggest thing with this, local area network. We used to do RTSP streaming with our cameras and trying to match video and audio, and in the world of IP, if it's not easy enough for the common user, if it doesn't work on their gigabit switch. I was just talking to Rutgers University. They have 2,000 gigabit switches deployed all up and down the East Coast, and they're all connected via fiber and everything. And it's a gigabit switch. It's not 5 gigabits, not 10 gigabits. So they have to be very careful about how much bandwidth they use. So it's great to hear that it works on a gigabit switch. Yeah. Let's talk about PTZ control. So you mentioned that NDI is going to basically help standardize control. For those of you who might be picking this up, so it seems like one cable can do power to the cameras, video over NDI-HX. And now you're saying PTZ control. Can you explain what that's going to look like and what that'll mean for a Wirecast user, a vMix user, a LiveStream user, or a TriCaster user?
Yes. So first of all, I should say that a problem that us software companies have faced is that every camera from every vendor is different to support. So, if you're like us trying to support a wide variety of cameras, you have to support Visca, you have to support Panasonic, you have to support, there's probably 5 or 6 different protocols. Then on top of that, every camera tends to have different settings. So to get a particular camera to work, even if it's, say, controlling, say, a Lumens camera or a Sony camera on a Visca protocol are totally different, because they have different ranges of settings, they perform differently. And so every camera's been different, which means that getting PTZ control in software reliably means that you pretty much have to develop the software for every camera separately. So now think, vMix needs to do it, Wirecast needs to do it, NewTek needs to do it. Everybody is needing to do this separately, and it makes for a world in which PTZ is just pretty hit and miss and pretty hard for, somebody buys a PTZ camera, and it often involves a lot of backwards and forwards between them and the customer, or between the vendor and the customer, and then the device that's actually doing the controlling. There's just this, it's very difficult to make work. So what we try to do is we're trying to standardize this so that in NDI, in the SDK, when you say, okay, I'm going to connect to this camera, what you get told by the SDK, yes, this is a PTZ camera. I support PTZ control. And then you can just tell the SDK, okay, pan to this position, and irrespective of what camera type it is, it will pan to that position. And so you no longer need to worry about how you talk to it, what the protocol is, what the IP address is, or the port number, none of that. You just connect to the camera, you're receiving the video or the audio feed, and we will direct and correctly change we will fully support making sure that camera can be controlled without any regard by the developer as to how to control that camera. And that is a kind of the holy grail here for certainly on the development side for broad PTZ adoption.
Yeah, that's such a huge value add for anyone adding NDI, which I'm just so glad you're adding that in, because normally they would be adding it just for the low latency video, or just for all the things. I guess it becomes all of these things that you're doing. It makes it just more and more valuable for people to use.
Well, we want, literally, you and I started talking about this probably a year and a half ago, and I remember us talking, and our goal was we want you to be able to take a camera, plug it into the network, and now it's available. You don't, there was never, the goal shouldn't be that you need to work out what the PTZ protocol is, or which port it's connected on, or what the daisy chain ID is, or what kind of port number and compression. I mean, that is not what is going to enable people to use video. What is going to enable people to use video is it should be as simple as taking your camera and plugging it into an SDI connection, but that should be on the network, and it should configure completely automatically, just show up as available. And that is what we're doing. And I think that NDI-HX really does get us there, and it builds PTZ control into that, and tally into that, and audio into that. And so hopefully it does more than, it's not just about the protocol anymore. We're talking about something that actually has real workflow advantages. That really it's never been the case that you could do that with a camera. So hopefully that's where we get to. And if it's not, we'll continue working on it. But that is where we're going, guaranteed.
Awesome. And I want to get to a Q&A. Hopefully, Tess, we have a real chat where everyone can answer Q&A. The last thing I wanted to ask you is, is NDI 3.0 going to come with additional tools? Because I know you have some great NDI tools that have been released. Some of them, like the video monitor, the NDI video monitor, it works so great on all these different devices.
NDI-HX to mobile apps soon. I don't know if that's.
Let's jump into the Q&A right after we run the credits.
Well, yeah, I just figured since you mentioned tools.
But okay, yeah. What
well,
was
the.
I can hear. Go ahead.
So, well, I can answer on the tools because we've actually made big improvements, and so things like we're now calling our video monitor application is now called Studio Monitor because it's got so many new capabilities that we gave it a new name.
Oh.
I'll give you one that this is the first place it's ever been mentioned actually, which is that we have, if you hook up a PTZ camera to, in Video Monitor, you can pull up a PTZ camera. It's there just like any other NDI source. You will see an overlay that allows you to do the PTZ control. But if you have any joystick of any kind connected to that computer, you'll be able to move your camera around, with a joystick. This is pretty cool. I mean, if you just think about a production, it means that you can have a second operator sitting on a laptop looking at the camera's output. They can now control it with a joystick. That's pretty cool. We've made a lot of improvements. The scan converter works better with what was a relatively mundane tool before, which was our test signal generator, now allows you to put your own patterns in there and things like that, so you can actually have your own images that you use in a show easily accessible. The thing is, we've done a year's worth of work, and it's probably a lot of it is little details, but man, those little details add up to big changes after a year.
So like an Xbox, like a wireless Xbox controller, or a USB controller, something like that would work?
Yeah, absolutely. That's exactly what I tested it with. Oh,
he's like,
perfect. See, that's going to work.
We just bought one.
We just bought one for testing.
We're going to play with it soon.
Oh my gosh, we're getting through this.
It's a lot of fun.
This feels good. All right. How to get through a rocky start of a live show. I'm going to roll the credits, and then we will jump into
And that's all, folks.
Q&A.
We appreciate your participation in the chat room and can't wait to host our next informative Q&A session. Your questions drive the conversation forward for live streaming professionals around the world. Until next time, happy streaming!
Whew. Man, you got me through it. You were like, come on, Paul, we can do this.
Aww.
It was just like a toggling of the